Yeah, that was the awkward one. Was that discussed? I won't think of it. I'm on. Just like
Good afternoon from, I assume, sunny Bangkok. This is a KITTEN working group meeting. I just had one of my presenters asking for a token to log in to present into MeetEcho, and I have no idea how to do that. Presenting it to register, and if you need a waiver token, you just send me email now. Okay. I'm going to CC you on email. Florian Schmaus. Sorry, I'm not very good in typing German's names, which has lots of. think. So apologies. Just trying to sort out last moment logistic for one of the presenters. This is KITTEN working group. And I'm one of co-chairs. I'm Alexei, in case you haven't met me. I don't know if Ben is going to be online. I'm not entirely sure about that. So this is KITTEN working group. We haven't met for a while, but recently there was some interest in two-factor authentication and related stuff. So we have some presentations about that. As usual, we are covered by Note well. I hope people are aware of this. If you're not, please make sure you're familiar with IETF procedures and documents. And as a reminder about IETF code of conduct, please treat various participants with respect, stick to technical argument, use best engineering argument. So we are being recorded. I think we have a note taker. If people can help out in notes and make sure that various points are recorded correctly, that would be great. Agenda. So we have 4 documents that we are going to discuss. 2 are related to quick reauthentication, which is HT family, and Remember Me. We will have a discussion about SASL passkey, which was an adoption call recently, which I didn't close because of some mixed feedback, and I hopefully will try to explain. Then there is update on Scrum 2FA document, which is I'm co-editing. I think Ben asked to talk about passkey first.
That's correct. Yes, thank you.
So in this case, what I would like to do is move you to the first slot. If the discussion becomes too controversial, if we spend too much time on it, we might have to cut it short and continue on the mailing list. And then I think reauthentication mechanism hopefully will be less controversial and quicker discussion.
I don't need to be the first slot. Can we just swap Remember Me and passkey, just the order, that's all?
No, because I think it would be useful to have two reauthentication mechanism one after another. That's why I'm moving you around a little bit.
Okay.
Okay, let me just keep talking a little bit. So in the last couple of months, we have several adoption calls. We adopted 2 documents on fast reauthentication. The documents are close enough, but there was...
Sorry, they should be able to look at the
Okay, thank you. Although the mechanism are similar enough, they have slightly different properties, and there was enough support to adopt both documents. Then we had a separate adoption call on passkey, and there will be a presentation about that. I think there was some concerns about existing APIs and how this is going to work. Also, some comments about out-of-band registration. My feeling is that I think we actually need to play with early implementations to resolve these issues, to find out whether the passkey is going to work or not, basically. Ben will talk more in details about how this is supposed to work. Okay. And then, Ben, I'll pass this to you. Are you going to present, are you going to share with Stephen?
Yes, correct. Mm-hmm.
Okay, all right. Fine. Let me, I think I need to, give me a second. I'm passing you slide control.
Thank you.
Okay, go, Ben.
Hi. All right. So hello, I'm Ben Boksch, and presenting together with Stephen Farrell. I'm assuming that you know Stephen. Some people might not know me. I'm coming from a mail client background, having been working on Thunderbird for 25 years as a core contributor, and now building a new client. And I would like to solve the problem for end users who have trouble, A, with the original setup, and B, staying logged in. So what is the problem that we're facing? Oh, too bad, the smileys are not coming through. That's really sad because they were a big part of the slide. But what's the problem? We have 3 general mechanisms to compare right now, passwords, OAuth 2, and passkeys. And we need to compare them together for the different stakeholders, which is the end users, client implementers, server implementers, and administrators. So what about passwords? Passwords for users are really easy. They know how to handle that. They get a password, they write it on a Post-it, they put it on their monitor, they type it, and that's fine, that's easy. The really smart people will put the Post-it underneath the keyboard. For clients, it's really trivial as well. The client just takes a string, sends it to the server, and that's it. And this client can save that string in a secure storage somewhere, and the next time it wants to log in, it sends the same string again. Client does not have to worry about expiry. It doesn't have to change password in typical use cases. And there is no need to deal with third-party servers, with other protocols, with the registrations, or none of that. Any client can implement that. The server cannot block the client. The client doesn't have to register. Everything is easy. For the server, it's just as easy. It takes a string, compares that with a stored value, and if they match, it's done. It's the administrators which have the problem here because passwords get stolen, devices get hacked, the accounts get hacked, and then the administrators have foreign agents in their local network, and they don't want that. So that's why passwords don't work in practice at the moment. One of the solutions is OAuth 2. How do they look like for the stakeholders? For users, they're horrible. OAuth 2 is really bad experience because they keep having to do the 2-factor authentication. That's really annoying. They have to take a second device, or it sends an email, and then I have to check the email and copy a code and paste the code. And I have to do that all the time. It's really annoying. And it's cumbersome, and users are not happy about that. Clients have a real problem with OAuth 2, especially a mail client that needs to deal with hundreds of different providers, because OAuth 2 requires a client ID, and this is not feasible that I register with hundreds of ISPs. So that fails the feasibility in practice. That's not really possible. For servers, OAuth is really easy to implement. They get an access token. They send the access token to the OAuth server. OAuth server says yes or no. Really trivial, easy. For administrators, OAuth is also easy. They just insert coins. They buy Okta or Office 365. Problem solved. So we can see here with OAuth 2, the server side is really happy, but the client side, both users and clients are really unhappy with OAuth 2. What about passkeys? Passkeys are really easy for users. They just have to smile into the camera and all is fine, or they press their thumb and they're done. So that's really easy. Clients, they don't know what passkey is. They haven't really heard about it. Servers likewise, but it's really easy to implement for them. They just need to store a secret or make an HTTP call to the authentication server and it's done. Administrators also don't need to do much because usually that's already implemented by their authentication server and is done. So passkeys might be possibly the happy place for authentication for all parties. So Stephen, next slide is up to you.
Oh, sure. Hi. I think you more or less said all this. I mean, I think the thing to reiterate, I think, is that for current mail user agents to be a generic MUA and support the kind of OAuth-based mechanisms is just a problem because you can't know all the client IDs that you need to know or register all the ones you need to register. And so that makes it kind of impossible to do a generic mail user agent with better authentication than the current ones. And we want something better for IMAP and for submission. So I think you more or less said all that. So you can go to the next slide, I guess. You have slide control, Ben, I think, yeah.
Okay, yes. And just to add to this, one single registration with Microsoft took me 1 month of work. That's really not possible to do. And then there's the testing involved. It's not really scalable.
Okay. So yeah, you go ahead, Ben. No, we don't need to repeat things.
Here, go ahead.
All right. So yeah. So basically, I mean, passkeys. I think it's worth exploring. Is the way to characterize it. And you know, it seems it's a pretty well worked out scheme. It's probably more complicated than you would need if you started inventing something new, but because it exists, that's probably a good reason to use it. I think you know, it can work with key fobs. It can work with platform authenticators. It can work, although I haven't yet tried it in this kind of context, with a mobile device as the key holder and a laptop as the mail user agent. That apparently works, but I haven't played with it. But because essentially touching the key fob or having the key fob present using NFC or sticking it in a USB slot is a bit too onerous for doing all the time. It's the kind of thing you might want to do occasionally. I guess, you know, similar to the way OAuth is done with servers, that they maybe every month they force you to redo the ceremony. I think the authentication ceremony would do something like that, maybe for mail. And then you need something like Remember Me or the hash token things to do the kind of constant re-authentication.
Yep. And so the idea here basically is to use the SSL passkey authentication method for the initial setup only. When I set up my mail client, as part of that process, I'm doing the SSL passkey. And then after I've completed that, that's when I get a Remember Me token. And then with the Remember Me token, that's when I log in and I stay logged in after that. Can we hold the questions for the end?
Sure.
So now this slide looks really, really complicated, but it really is not. It's basically just 2 calls that are being passed through all the different systems. So how does it work on the web? I'm logging into to the website that I want to authenticate with. I'm logging in with some other mechanism or a register, and I'm on my profile page in the security section. I say add passkey, and then what the web page does, it calls the browser one single browser API called navigator.credentials.create, and the browser just passes that on and makes one operating system function call. There's one C function or whatever Java function which goes to the authenticator, and the authenticator is then creating a new public and private key pair. It stores the private key securely and for that particular site, and returns back the public key. And then the public key is being passed through the browser to the web page. The web page then passes that public key to the REST server. That one then sends it to the authentication server. It stores it. Thing is done. So it's basically just creating a public private key and storing the public key on the server. That's it, basically. For the login, it's almost as simple. So what happens is that the authentication server generates a challenge, a random string, and returns that via the login page. The login page then calls a single browser API called navigator.credentials.get. The challenge is a parameter to that function, and the result is a signed challenge. Again, the browser doesn't sign it itself. It passes that on verbatim the challenge directly to the operating system, to the authenticator or password manager. Again, that's a single C API call or Java API call with a challenge as parameter. The authenticator then takes the random string, signs it with a private key, and returns that signature. The signature is then passed through all the different stages, verbatim from the browser, web page, REST server, back to the authentication server. The authentication server checks whether that matches the public key for that particular user. If so, it returns OK, and you log in. So again, that's basically a single function call that is going through all the different parties here. So now it's interesting, how would that work for mail? What is our proposal? And, oops, sorry. So let's quickly compare the two slides. This is how it looks for mail. I go back. This is how it looks for the web. Do you see the similarity? On the left side, absolutely nothing has changed. We do the registration still in the browser. It is exactly the same registration. And again, the authenticator is the same one that we use for the browser. By the way, it's the same is true for the web system. The whole system on the web depends on the fact that the authentication server and the auth server always stay the same. And in our method, that's the key also for this method to work. The authenticator stays the same, so I can register my passkey in the browser. In the mail client is just doing the function of the web page and the browser. If you compare that, the mail client, the SSL passkey mechanism, just replaces the web page and the browser. So what does it do? Again, we get a challenge from the server. So we issue the SSL passkey mechanism. The server responds with a random string as a server. That's the first exchange. The mail app passes that challenge directly to the authenticator by the password manager. Again, a single API call. The authenticator signs the challenge, returns it to the mail application. The mail application returns the signed challenge verbatim to the server. The server passes that on the IMAP server, passes that challenge, the signed challenge, back on verbatim to the authentication server, which checks it. So neither IMAP server nor the mail app are involved in any of the complicated crypto stuff. They just pass on the challenge and the signed, the signature verbatim as is. And the mail app just has to make a single API call to the authenticator. And it's exactly the same call that the browser makes. Back to you, Stephen.
Oh, great. Yeah, so I think you said all that already. Other than, yeah, so I mean, there's passkeys is hopefully on the client side handling, there are libraries to handle things like crypto fobs using YubiKeys or other kind of crypto fobs. The generic idea of having a kind of origin-based key signature scheme is not entirely new. We had a thing called Hobo we proposed with RFC 7486. browsers didn't want to adopt that, so it never went anywhere. Next slide. Again, I think Ben covered most of this. Ben, if there's something you didn't cover, that's fine. And then the next slide, just to keep some time. So there's so one of the things is the web authentication passkeys spec is it's slightly distributed because they're dealing with both these APIs that Ben described and interfaces to things like just key fobs or enclaves and operating systems and so on. So but I think that this web authentication spec link here seems to be the kind of key one. In terms of implementing, or how easy it is to implement what we're proposing, Aki Tony really quickly did a proof of concept implementation, essentially building in some API calls to do the authentication verification into Dovecot code, into the Dovecot code base. It's not necessarily, I haven't actually run it live in Dovecot yet. And then I started building up because there are so many flavors of different ways of using passkeys, I think we need to convince ourselves this is all going to work. I think we'll need a kind of a bunch of how to do it in this combination of things and how to do it in that combination of things and so on. So I started building up a kind of repo there that has initially how to kind of build a virtual machine running Ubuntu that has Dovecot and Thunderbird and so on, and that interfaces to YubiKeys or some other crypto tokens that I've gotten a hold of. And also in Aki's work there, he's linked in a Python library that essentially can do the registration and authentication steps of passkeys. So it's not the case that you necessarily need the full browser. But again, we need to learn a bit more about this stuff as we go. And there was one more slide, was there? Yeah. So I think the next steps are, I think it's worth adopting. If experimentation proves that it doesn't work or is unacceptable, then we can stop. I don't think we necessarily want to try and have demonstrated this works in every feasible combination before adopting it in the working group. But we definitely do need to do the experimentation and iterate on the specs and experiments. And I think we'll also need to build up a kind of a batch of different kind of how to use this in different contexts, whether it's using a mobile operating system to hold the private keys versus using a cryptographic token that you touch and so on. But so far, I think in the experiments we've done in the last month or so, it's looking more and more feasible. How ultimately usable it is, I think that'll be the question. But I think feasible is, I'm getting more convinced that it's quite feasible. I think that's all slides.
Yeah, just to add one more thing, because there was this question on the mailing list, how to implement that. Like I said, on the mail client, you basically just make a single API call, and that API call is standardized by FIDO in the FIDO specs. And there's existing implementations. You just need to look at the Firefox source code, and it's implemented there. And I have a wiki page where I'm linking to the specific implementations on every operating system where Firefox implements it. So we just need to make this exact same calls. And there's the specifications for that as well. Alexei, should we take some questions and use like 1 or 2 minutes that we wanted to use for Remember Me?
I will probably forego my presentation at the end, and I will allow 5 minutes of discussions. We're running a bit late, but I think this is important enough too. So I think Tim was, are you Tim? You're Tim. Oh, you're Tim. Okay. Go ahead then.
Yeah, so Tim Cavalli, sorry if I repeat myself. I didn't get any responses to the mailing list response. So a couple of things I just wanted to clarify, right? It was not clear to me when I wrote that response that the Remember Me would be used with this, right? Because if we remove the client ID piece from OAuth, popping a browser using a passkey to initially sign in, then issuing a token that's then used from then on out is how passkeys and OAuth and apps are deployed today. That is fundamentally how all of this technology is used. And you could do that because OAuth has dynamic client registration and the client ID does not have to be an issue, right? So I just want to be very clear that is possible today. That is how people deploy apps in the world today. And there's nothing unique about this situation. So just one clarity there. From the protocol standpoint, while it is the same API call for you as the mail app, your mail app is not entitled to get signatures for a origin you do not own. That is the fundamental problem here, right? Like, if you are Microsoft Outlook and you want to get signatures for a Entra ID or Microsoft passkey, that's great. You're entitled to do that because it's first party. A what's another mail client? Thunderbird. Sorry, I'm stuck in Gmail hell enough to use the web. I would love a mail client. Thunderbird can't get an assertion for any other passkey because they're not an IDP. They're not a relying party, right? That's fundamental to how passkeys work. It's by design, and there's like no like that is how WebAuthn works.
But just to address that, I mean, so I think the model here is that it's the mail service is the relying party in passkeys terms.
Correct. And the mail service has no relationship to your mail client, no organizational relationship.
So
Unless
can I answer that?
Microsoft and Microsoft.
Can I answer that? So in this system, the mail app replaces the browser. The mail app has the same function as the browser. The mail app can authenticate to any number of email services, just in the same way that a browser can go to any number of websites. And the mail application will say, I'm trying to authenticate to this host now, for example, to imap.gmail.com. So I need the passkey for gmail.com. And it has the exact same rights as the browser has because it's an user agent that's running on the user's machine in the same way that the browser does, in a very real way, because Thunderbird is literally the same code base as Firefox. So they're on the same level. And it's the browser who's saying, I am on whatever.google.com, and is saying that to the authenticator in the same way Thunderbird would say, I am trying to authenticate to imap.google.com. I need the passkey for that site. So they're exactly on the same level. And it works in exactly the same way.
But again, that's an assumption. This is where I think reality might be disconnected from ideals, right? Like you would not just inherently be able to act as a browser, right? That's not how
What would stop me from doing that?
Your code could not execute, like it would fail, right? Like you're not a browser, right? Like browsers are WebAuthn clients and have certain privileges.
Well, literally is the same code base as Firefox. It's literally the same.
But that doesn't mean it automatically works. Is my point here, right? Like
what I said, what would stop it?
Should not be able to get a signature from every single passkey user has, right? It's not your role as a mail client. Right, there are mechanisms for getting signatures from other origins, which is using web technologies like web views to then allow the user to sign in, have a nice experience, and get a token back. Again, that's exactly how everything works today. Giving a mail client extremely high privileges for the user to sign into one origin is a pretty dark pattern.
So on the point of whether a mail user agent can use these APIs successfully, there are libraries and where that does work. I've used the Python client, the Python code to access the passkeys with YubiKey, and that works. And I don't see any barrier to it working in at least some cases. There may well be issues, and I haven't experimented with the cases where the private key is in the mobile operating system. So there may well be more constraints in some scenarios for deployment than others, but it's not the case that passkeys kind of prevents this from working. I don't think that's the case.
Okay, I'm just trying to give you feedback on. I don't want you to waste your time, but
So again, I mean, there are libraries for using passkeys that don't depend on being a browser. And those work.
There is code that you can run in a highly privileged environment on the device that allow you to talk directly to a security key. That's not where users actually have their passkeys, though. Less than 1% of users have their passkeys on a security key.
Yeah, that granted, yeah.
I figured I should hop up to the microphone to say this for people who are remotely, because I was heckling from the crowd. Yeah, the email client is a user agent in the same way the web browser is a user agent. If you are on an operating system which allows you to run an open source web browser, then there's no reason that you can't run an open source email client in the same way. I don't think you can block the email client from working like a web browser without blocking all but assigned set of web browsers, which I would say is very much a dark pattern to only allow web browsers by a very constrained set of vendors. So I don't see the issue.
Okay, I think this is part of why we need to experiment. I think there are some early implementations, but we need to get more feedback whether this is going to work or not.
Why not experiment with the patterns that exist already that are deployed by hundreds of thousands of apps?
So if there's discussion in the room, it's not audible to remote participants, including this one.
Sorry,
Likewise,
I guess what I'm
and
pushing
we
back
have
is
a-
like, why
we
not?
have a- We have a queue. Can we maybe
didn't
follow the queue? We have Arndt and Dean in the queue.
Wow, I didn't realize Tim was that tall. Dean Sachs, I strongly agree with Tim here. I think Tim has the right idea. Having worked closely with the FIDO Alliance, I will say that I think it would behoove this group greatly to engage directly with members of the FIDO Alliance and understand where the ecosystem is, where the ecosystem is going, and how you can work within that ecosystem. Ultimately, I think, and I've said this on the mailing list, I do believe OAuth is the right pattern here, and then the user can bring whatever authentication credentials they have to bear, whether it's a passkey or a password or whatever it is, to the party. OAuth is the appropriate pattern. There are plenty of OAuth experts here at IETF who can help you with that too. I think if you want to continue down this path, it's fine. But I would urge you to talk to experts on FIDO and passkeys and OAuth before diving further down this pathway. Thanks.
Sure. Thanks. Arndt, did you want to say something?
Yep. Since we have Tim here, is there anything core to passkeys that prevent an application such as a mail client from asking the web browser on the same device to perform registration and make a private key that the not web browser application can then use? Is that kind of not possible for architectural reasons, or more of a smaller problem right now? That's all.
So just to be clear, right, you can create a passkey in the browser for mail.example.com and access it from a native app that is responsible for mail.example.com. That's how everything works, right? But you do not actually, a mail client for example.com cannot get a assertion for outlook.com.
What does it, email client for example.com? That thing doesn't exist. That's not a thing.
Exactly.
Well, okay.
Just
so,
a general email client will have a specific registration with specific IMAP server which has to have associated
well, so
website.
it does exist, right? Like the Outlook, for example, tied to Microsoft. I want to just highlight first party versus third party. That's the key differentiator here. It is the core tenet to WebAuthn, right? Passkeys are first same party to the relying party to the app.
We're not talking about that. We're not talking about the Outlook mail app. We're talking about Thunderbird, which can go to any email provider.
I understand, but I was using the example he gave, right? You can create, if I am on example.com in a browser, I can create a passkey for example.com, and any app, which is also first party for example.com, right, can also use that passkey, right? That's how we make passkeys work.
I think that's the use case we have.
But you don't have it. What I'm hearing, the reason I said first party, you're saying you don't have any first party use cases. Everything is third party. There is no relationship between the mail client and the web server, the backend service.
So I think there's a terminology clash here. So I think in the mail client, the goal, or our goal, I think, is to have a generic mail user agent that can work with multiple mail services, with different accounts and without really being constrained to be bound to one mail service. And the first third-party kind of idea from the web is not really directly applicable in mail. You want the MUA to be generic for any service. That's the goal. Whether we can achieve that and how that interfaces with other, various flavors of passkey support is where we need to experiment.
Right. No, and just to be clear, I very much understand the use case, but you are operating in the context of WebAuthn, which has a certain set of requirements, right? So again, you could, and why I put myself in the queue originally is, I agree you should experiment. We should experiment with the exact patterns that are used today for this use case that are deployed by hundreds of thousands of apps in the ecosystem, right? Where you can use a passkey from the web in a native app. If it's your first-party native app, you can call the APIs directly. If not, you can pop a browser, get a token back, and bring the user back and use the token from another app.
At least speaking personally, it's another goal of mine that the work here would work for a generic mail user agent that is not bound to a specific mail service. I think that's exactly what I just feature of the mail ecosystem that we're losing and would like to get back more of if we can.
Exactly.
What I just described is exactly what you could do, right?
Yeah.
To add to this, the specific purpose here is to not use OAuth and to not depend on web browsers and to not depend on web servers, because this is a mail protocol. We don't want to open web browsers in the mail app. That's the goal here. So that completely rules out OAuth from the get-go.
But okay, but that is those are the guardrails you're operating in by using WebAuthn, right? Like it is a web technology that has been adapted to the app platform and has the same limitations in the app platform as it does on the web platform, right? So like this is how everyone does authentication, right? Like if you are not first party, right? If I have a native app that I can offer sign in with passkeys to users, that's great. You as the service have the passkey for the user, but the minute the user chooses to use a third party service like sign in with Google, you have to pop a browser. Right. That's.
So, okay, Tim, I think there is a concept clash here, because imagine that my mail client is my browser. The mail client is a user agent in exactly the same way that a browser is a user agent. And the mail app is trusted in exactly the same way as a browser is, because I install my mail client in exactly the same way I install my browser. So in your mind, don't replace mail client with web app or with Outlook app, but replace mail app with your browser, and then the system works.
Okay, so if you're operating in a browser, you can do you can do OAuth and redirect the user, pop up, redirect, whatever it may be, and come back. Like you're making the assumption.
No, I'm not operating in a browser. I am.
But you're not, right? Like that. We can continue to say that, but like again, I'm trying to bring the reality of the ecosystem that's I don't believe going to change. You're not a web browser. You are not entitled to get assertions for realms you don't own, right? That's the only app on a device that can do that is a browser.
I think we need to continue that on the mailing list, because I think we're going.
Yeah, I think we should take it to the mailing list. You have 15 seconds.
15 seconds. All right, Ben, I think the disconnect here is Thunderbird may operate as a browser, but every other mail client that I use does not operate as a browser. And that's the fundamental disconnect here. Those that do not operate as browsers are not going to be able to get an assertion for an RP, a relying party, that in your case, an IMAP server, for instance, that they are not a first party too. And so that is the fundamental disconnect here, and why a passkey won't work in this environment outside of using a pattern like OAuth. And with that, I'll sit down.
Okay, all right. Okay, thank you all. I think I will give Florian mic to talk about SOSL HT, and if we run out of time for Remember Me, then I'm afraid so be it. Okay, so. Sorry. 1 second, Florian, I'll just share slides.
Yes, no worries.
Okay, confirm, and then. Okay, I'm passing you control.
Yeah, that looks good. Okay, hello everyone. My name is Florian. I'm a systems software researcher at DAY. and at night I tend to hack at things. And one of those things is XMPP, but that's not actually what I want to talk about today. Today I want to talk about the hash token SASL mechanism, which originated as part of my work within the XMPP community. So first, some motivation. We are focused on application protocols that are using a persistent connection. And in this modern time and age, connection reestablishments become more and more frequent, as it has been 15 years ago, 20 years ago. And the problem is that, especially in XMPP, but I believe this applies to other application protocols as well, connection reestablishment takes a long time. It takes so long that it seriously hurts the user experience. Just to give you some numbers, they are pretty dated because they are from my FOSDEM 2015 presentation. That's how a typical XMPP handshake looks like, with 80 milliseconds round trip. I believe 80 milliseconds is no longer state of the art. Still, there are regions in the world where 80 milliseconds are still the case. So as you can see, basically, XMPP connection establishment takes around 2 seconds, and that's too long. Of course, XMPP being modular, it has accumulated a lot of features over the years, and all those features have to negotiate it more or less step by step. But one thing that stands out in this table is the SASL phase, which takes roughly half a second. And this is due to the SASL mechanism using a lot of round trips. I believe this used SASL Scram, which is like one of the strongest SASL mechanisms we have. And it involves quite a few round trips to get it done. So we want to focus on reducing this time for the SASL. In fact, we want to reduce the overall XMPP reconnection time, and the hash token SASL mechanism that I'm going to present is just a small building block in a bigger picture. First, XMPP is moving towards the extensible SASL profile. And that basically means that SASL is now the outer layer of authentication or of connection reestablishment. And what was previously the outer layer is now the inner layer. That's the bind phase in XMPP. That is, amongst other things, responsible for all the future negotiations that we saw before. That's all done in a single step now, or is hopefully going to be done in a single step. And then we have fast authentication streamline tokens, which is another XMPP extension protocol. And at the heart or at the core of it there is a hash token SASL mechanism, which is used to authenticate, and the fast authentication streamline token XMPP extension is used to obtain the tokens that we are going to use later for re-authentication. So again, SASL HD is just a small building block of a larger picture, but nevertheless, it's an important building block. With that, I'm going to talk about how this mechanism is designed. It's the name already reveals. It consists of two important parts: a token. So we use this token as a proof of possession scheme to quickly re-authenticate a connection once it got disconnected, maybe due to a Wi-Fi GSM switch or something like that. And we obtain the token after we initially authenticated using a strong SASL mechanism like Scram. The token is required to be cryptographically generated, derived from a cryptographically secure random number generator, and to contain at least 128 bits of entropy. And the SASL HT mechanism requires an application protocol specific extension to obtain the token. I already mentioned the XMPP extension protocol, fast authentication streamlining tokens. And there's also instant stream resumption. But the core takeaway is that you need an application protocol extension to somehow obtain the tokens, because that is outside of the scope of the SASL HT specification. Then another part, or another important building block of SASL HT is that it's a hashed token. The token is protected by this hash. It's basically the HMAC construct. And for additional security, we use TLS channel binding data to mix in as the key of the HMAC function. And as benefit, we get mutual authentication between both endpoints. We believe, or I believe, even without channel binding data, attacks on pre-computed hash values of the SASL HT token seem impractical, given that the token is at least a 16-byte number. Why do I say that? Well, some ecosystems do not support channel binding. The very first draft of the SASL HT ID required channel binding. And then later it was found that we want to use SASL HT in environments where channel binding is not available. And therefore we added a special channel binding type to SASL HT, the non-channel binding. So how does it work? Basically, the server generates a token and sends it back to the client over a securely authenticated channel, think SASL Scram. And then for some reason, the connection gets interrupted. So the client has to reconnect, and we want to make it fast, want to make the reconnection fast. So what the client does is it derives the hash token of the initiator, that's the HMAC construct we see here, and sends it to the server. The server is able to verify this hash token and does the same with a small modification for the key. Instead of initiator, we concat responder to the channel binding data. And in its answer, the server sends back the hash token for the responder, and the client is now also able to verify the result. And if both verifications are successful, then we have successfully authenticated the connection, and both sides have been mutually authenticated. What's the current status of the XAP, of the ID? So within the XMPP community, we saw a lot of traction of the XAP fast extension protocol, and this extension protocol uses SASL HT. Therefore, SASL HT has seen wide adoption, I would call it. I think most major XMPP software stacks implemented it in one way or another. So I'm pretty confident that it has been a success so far. It's still an experiment to some degree, nevertheless. And in the latest XAP, there was in the latest version of the SASL HT draft, there was a change to the wire protocol. Basically, the responder message can now signal an error condition. This was added to be on par with existing SASL mechanisms, which all have this error condition signaling, which SASL HT lacked. So now the question is basically how should we deal with this wire format change, given there are already deployments? We could rename the mechanism to HT2. We could ignore that and expect implementations to do a fallback to the old or new wire format. Maybe we can do something else. All in all, there are not many open questions, at least from my side, and at least that's the feeling I have talking to various people who implemented it. The only outstanding question from my view is a little thing called the zero RTT data. So TLS 1.3, as many of you probably are aware, introduced the zero round-trip data. And while I'm not aware of any implementation actually using it, I don't think it's sensible that we close the door for this. Instead, we should try to design our protocols in a way that zero round-trip data can be used. After all, that's the ultimate goal, to speed up the reconnection process, and zero RTT data is can help with that. But the question is, when it comes to zero round-trip data, is what should be contained in the zero round-trip data? And SASL HT and the instant stream resumption SAP requires the TLS round-trip data to only contain the data that is required for authentication, while the XAP Fast and others went a different route, where they also show further data besides the data that is required for authentication into the zero round-trip data. And it's debatable how secure this is. But yeah, that's an open discussion. We had a discussion on the XMPP mailing list, but we did not reach a conclusion yet. So with that, I thank you for your attention, and I'm happy to any questions you may have, to answer any questions you may have. Okay.
Arndt, did you want to comment on this?
Absolutely. Looks neat. However, it seems to me that this is very strongly tied to a single TCP connection, meaning it seems a little in conflict with happy eyeballs and with the multiple connections, with the several connections that many mail clients use. For example, it's reasonably common for one mail client to open a connection, authenticate, and then just enable idle mode and listen for changes, and use another connection to do everything.
Yeah.
What happens? No, my question first. What happens if you try to open 2 or 3 connections at exactly the same time with this? Has this been considered?
No, this hasn't been considered, but that's basically the question: how quickly you burn the token, right? So that seems to be a question that's up to the application protocol, how quickly the token is invalidated. Is it invalidated after it's been used once, or is it invalidated after 5 minutes after it has been used once? If you do the latter, then you can use SASL HT for the scenarios you described pretty well, I think. You can create multiple connections, authenticate using SASL HT with the same token for these multiple connections, and keep them established. Another way, of course, would be, and that's also part of the application protocol specific extension, how many tokens you hand to the client. In this example, there's only one token given to the client, but you could also give 3 tokens to the client. And then it could use those 3 tokens to authenticate to authenticate 3 connections.
Right. I think you're saying that there are no deep security properties that depend on invalidating the token after a single usage. Is that correct? Doing something like a minute or 5 minutes is...
Yeah. That's exactly what we are currently experimenting with. How long should the token be valid? Yeah, exactly. That's an open question for experimentation, I'd say. I saw that Matthew Wild is in the participants list. He's an XMPP server developer. I could imagine that he has an opinion on that. But besides that, there is no hard constraint yet.
Yeah, in XMPP implementations, we're currently rotating daily, I think, by default. But yeah, I don't think that you have to change it immediately on usage.
I think from a security standpoint, maybe granting multiple tokens, if you want to establish or re-authenticate multiple connections at once, is maybe a little bit more secure, but that's just a gut feeling of mine. Okay, any further questions? Alexei?
We are over time, so I'm going to email my answers, or questions about renaming the mechanism and why you wouldn't want to do one or the other. I have a slide suggesting next steps, but we really kind of ran out of time. I'm wondering whether people are interested in continuing discussion on the mailing list and maybe having an interim in a month's time or so. Can I get a feel of the room, both local and remote, if people are interested in interim?
Can you repeat the question once more?
I'm suggesting, because we ran out of time and there seemed to be enough interest in this, I suggest an interim online meeting in a month's time, and Steven suggests maybe a bit more than a month's time.
Yep. Sounds good.
Sounds good.
All right, I'll send email to the mailing list and try to see how much interest. And just a quick note. So we have the passkey discussion, which is unresolved. I think that needs to continue. There is also a separate discussion about a faster authentication mechanism, which are useful independently on whether or not will work on passkey, because there are other things that can still be. Faster authentication mechanisms can be used with other authentication SSL mechanisms other than passkey. So we have some examples of this. Okay, thank you very much for coming, and I'll try email the mailing list on next steps. All right, thank you all.
Thank you, bye.